Perpendicular bisectors. A. Perpendicular. And we're going to use this symbol from now on for perpendicular. Not going to write that big long word anymore. A perpendicular bisector of a segment intersects the segment at 90 degrees and divides it into two equal parts. A perpendicular bisector of a segment intersects the segment at 90 degrees and divides it into two equal parts. So if you've got a segment, let's say this horizontal segment is AB, and then a vertical line or segment, we'll call this CD. And let's say that CD intersects AB at point E. If the angle of intersection is 90 degrees and AE is congruent to EB, CD is a perpendicular bisector of AB. Everybody good with that? So this is real important. Definition of a perpendicular bisector. And this is going to be real important. Any point on a perpendicular bisector is equidistant from the endpoints of the segment. Any point on a perpendicular bisector is equidistant from the endpoints of a segment. So we already said that since CD intersected AB at 90 degrees and AE was congruent to EB, that made CD a perpendicular bisector. Any point on a perpendicular bisector is equidistant from the endpoints of the segment. So point C up here is on the perpendicular bisector. So what this definition means is that point C is the same distance from A as it is from B. So this here is also true. AC is congruent to CB. The same would be true for point D. Point D is on the perpendicular bisector, so D would be the same distance from B as it is from A. these pieces would be congruent. AD would be congruent to DB. Those are the rules that you need to understand about a perpendicular bisector. The converse of this last statement is something that you have to understand. If a point is equidistant, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector.
Teachers, at this time, we are going.
Oh, we can keep taking notes. Door's already locked. Okay, so here's what you have to understand about the converse of this statement. If you're given this picture, and you've got X, Y, and Z, and on this horizontal line you've got M and N. Now if you take a segment and you draw it from X to N and from N to Z, if X to N is congruent to N to Z, that means you've got a point that's the same distance from the endpoints of a segment. Well, this converse said that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So now if you're given this picture, what you have to understand is that this angle, XYM, is 90 degrees. And X to Y is congruent to Y to Z. That's the converse of the theorem. So you need to understand both parts of that theorem. You need to understand the definition of a perpendicular bisector. You need to understand that any point on the bisector is equidistant from the endpoints, and that if a point is equidistant from the endpoints, then it is on the perpendicular bisector. So let's look at a couple problems on the top of page 325. You might be better off just looking in the book and then up at the wall instead of trying to draw these pictures, because I think drawing the pictures actually takes longer than doing the problem. Because example 1A, you've got a segment and it's intersected by a line. The segment is BD, the line is CA, and you're given a segment from B to A and then A to D, and you're told this, that angle BCA is 90 degrees and that BC is congruent to CD. If that's the case, then what is the horizontal line called in this picture? Good. A perpendicular bisector. And since it's a perpendicular bisector, any point on the line is equal distance from the endpoints of the segment. So how far would it be from A to B? 4.1. Very good. If you were given this picture, a vertical line that intersects a horizontal segment, on this line you've got point X and point Y. The ends of the segment are at W and Z. X to W is 9 and X to Z is 9. This angle right here, the angle of intersection is 90 degrees, and Y to Z is equal to 3. You're asked to find how far it is from W to Y. Well, if point X is the same distance from W than it is from Z, then it sits on the perpendicular bisector of a segment. And if X to Y is a perpendicular bisector of W to Z, and YZ equals 3, then how far is it from W to Y? 3. Alright, let's do one more of these with where you've got to write an equation. It's going to be example C on that same page. You've got a vertical segment intersected by a horizontal line. The endpoints of the segment are Q and T. Point on the line is R. Q to R is 2x plus 3. T to R is 4x minus 7. And the given information is that the angle of intersection is 90 degrees, and Q to S is congruent to S to T. Since that given information, since the lines intersect at 90 degrees and QS is congruent to ST, that makes point R, or line RS, a perpendicular bisector. And if that's the case, then R is equidistant to the endpoints of the segment. So RQ is going to be congruent to RT. So with that, you can write your equation. We're trying to find, in this problem, length of RT. So you're going to set your 2x plus 3 equal to the 4x minus 7. You can solve for the variable now and substitute. So subtract 2x from each side. 3 equals 2x minus 7, and then add 7. And if 10 equals 2x, you can divide by 2, and 5 is equal to x. If 5 is equal to x, you can substitute it into the expression that represents RT. So 4 times 5 minus 7 is 20 minus 7, which is 13. Alright, so that's the definition of a perpendicular bisector and two theorems, or a theorem and its converse, that relate to perpendicular bisectors.